So we're going to factor trinomials when a equals 1. Okay, so for a, I've got x squared plus 7x plus 10. And just like I mentioned at the beginning of the lecture, we want to factor this into the product of two two-term expressions, or two binomials. Okay? Here's how the method works. Both of these binomials would begin with x. So you write x and x as your first term for each of those binomials. And then we do a little bit of thinking here. Okay? You remember last time how these two numbers multiplied to equal, which one? Was it the number at the end or the number in the middle? Let's go back and check here. So these two numbers, they multiplied to equal the number at the end, and then they added to equal the number in the middle. Okay? So we're going to do the exact same thing here. We're going to use that backwards intuitive understanding of how to factor these two polynomials. Sorry, this polynomial. So what I need is I need a factor pair of this term, 10. I need a pair of numbers that multiply to equal 10 and add to equal 7. Okay, maybe I'll just write those symbols underneath. They need to multiply to equal 10 and add to equal 7. That's my goal. Okay? Sorry? 2 and 5, right? You can just think of the factor pairs that multiply to equal 10, right? Sometimes it helps to just list them out. So I've got 1 and 10, right? 1 times 10 is 10. I've also got 2 and 5. 2 times 5 is still 10. Anything else? Any other factor pairs that would multiply to equal 10? No, right? The correct factor pair would be the one that, when I add them together, I get that middle term, 7. So obviously it's 2 and 5. Okay? So I put plus 2 here, plus 5 there, and I'm done.
Wow, that was really easy.
Okay? How can I check? How can I check to make sure I'm correct? There is a way.
Oh,
Multiply?
Yeah, multiply it out. If I multiply it out and I end up back where I started, then I know I've done it correctly. So let's just do that really quick. Distributive property, or FOIL. Okay. Remember, all we're doing right now is checking. We're not actually answering the question anymore. We're just checking to make sure we're correct. So x times x is x squared. X times 5 is 5x. 2 times x is 2x. 2 times 5 is 10. Add those two middle terms together to give me 7x. And did I end up where I started?
Yeah.
I did. Okay, so I know I'm correct. Yay for cheating. Okay? So just to recap again, when we were factoring this trinomial into a product of two binomials, which sounds like a lot of math speak, okay, but we're looking for a factor pair, or two numbers that multiply to equal 10 and add to equal 7. Good? Okay, let's get to the next one here. Let's do B. Okay? So B says, what do we got? X squared plus 4x plus 6. Okay, so again, I want to set up my brackets here. Both of them begin with x. And I want two factors that multiply to equal 6, add to equal 4. What would those be? Multiply to equal 6, add to equal 4. Just think of the factor pairs of 6 for a moment. What are some numbers that multiply to equal 6? 1 and 6. And 2 and 3. Okay, good. So what's 1 plus 6? 7. Well, I want 4. That's not going to work. 2 plus 3? 5. Still not 4. Are there more factor pairs? Did we miss one?
Just make one negative.
No, that wouldn't work either.
1, 2.
Did I trick you?
No.
Yeah, not factorable.
Well,
Done. Okay, not factorable with integers. There's little tricks you can do to sometimes factor these using radicals, using even complex or imaginary numbers. What?
Imaginary numbers.
Yeah, which makes me sound like a crazy person, and I wish they didn't call them that because that makes them sound like they're fake, and they're not. But that's for another day. Okay, so let's stop goofing around. Oh, let's do C now. Hopefully this next one will be factorable, which it will be because I can see it. So x squared minus 29x plus 28. So again, two factors that multiply to equal 28 and add to equal negative 29. Don't miss that. Okay. So give me some factor pairs of 28.
28 and 1.
1 and 28, thank you. What else?
14 and 2.
2 and 14.
7 and 4.
4 and 7. I keep going backwards, but that's
Yeah.
okay. Anything else? Is it divide by 3, 5, 6, 8? I think that's it. Okay, so which of these add to equal negative 29? None of them. Bummer. What do we do?
Uh-oh.
Could I change the signs of these factor pairs to make them equal negative 29?
Sure.
Yeah. Which one are you going to change the signs of, do you think? 1 and 28, right? If I made this a negative 1 and a negative 28, let's see what happens. Okay? So I put negative 1 here, negative 28 here. Let's see if that works. Okay? So negative 1 times negative 28. Does that equal positive 28?
Yeah.
Yes, because negative times negative is positive. Negative 1 plus negative 28.
Negative 29.
It gives you negative 29. It's like saying it's negative 1 degrees outside and it drops 28 degrees. What's the temperature now? Right, negative 29. And again, we could check by multiplying. Okay, we'll just do that quick here. So we distribute both the x and the negative 1, giving us x squared minus 28x minus x plus 28. So, oops. It worked. Okay, so we know we're right. With me? Okay, one more and then I'll get you to try it on your own here. Actually, you know what? I'm gonna keep doing the rest of them. And then I'll give you a few on your own. Okay, so we're gonna factor 3x squared plus 18x minus 81. This is gonna be tough. Do you notice a problem with this question already? Yeah, there's a 3 at the beginning. So can we do normal factoring? No. At least not yet. Okay. I did this intentionally because I wanted to prove a very important point. Whenever you're doing any kind of factoring, watch out for greatest common factors. If you can factor a greatest common factor, always do that first. So, looking at this problem with that perspective, is there a greatest common factor that we could take out? 9?
No.
No.
7.
27? You can go 3 divided by 27?
Oh, I see.
No. 3 is the highest thing I can take. Right? So I'm going to factor that 3 out. What's left over? X squared. And then 18x over 3 is 6x. And then 81 over 3, 27. Sorry, that should be a negative 27. Ugh. My eraser works a lot better now. I can erase whenever I want. So happy. Alright? So now we're only concerned with this inner trinomial. Okay? Okay, that 3 in the front, he's just going to act like a bystander. Okay, when we factor, he's just going to be in the outside like this. Okay, so just put him out in front, and then we're going to factor the inside like we have been all along. So again, I want two numbers that multiply to equal negative 27 this time, and add together to equal positive 6. So I think of the factor pairs of 27, and what do I have?
3, 9.
3 and 9, what else? 1 and 27. Anything else? No. Okay. So they need to multiply to equal negative 27 and add to equal positive 6.
Negative 3, 9.
Yeah, you're seeing it now, right? If I made this 3 negative, what would happen? Well, I have negative 3 times positive 9. That gives me negative 27, right? Negative times positive is negative 27. With me? And then if I go negative 3 plus 9, or vice versa, 9 minus 3, that gives me 6, just like I want. Okay, so those are my factors. I've got plus 9 minus 3.